everyone. In this topic we are looking at water, and in this lesson we will mainly focus on the properties of water. So we already know that water has very unusual properties compared to other substances, and we know that this allows water to play very significant roles in the world. So now we will look at some other properties of water, such as we will focus on hydrogen bonding. We will also look at how water acts as a weathering agent in our environment. So these are the two things that we will mainly focus on this lesson. So first look at the significance of hydrogen bonding. Now what is hydrogen bonding? Hydrogen bonding is the attractive interaction. So it's an attractive force of a hydrogen atom with an electronegative atom such as nitrogen, oxygen or fluorine. So it's a strong attractive force that causes the hydrogen atom to bond or to form an attractive interaction with an electronegative atom, which can be nitrogen, oxygen or fluorine. So let's look at what that means. So let's look at a water molecule. So a water molecule has an oxygen atom and two hydrogen atoms. And now oxygen is very highly electronegative, so the electrons go towards the oxygen atom, which gives oxygen a delta negative charge and gives the hydrogen a partially delta positive charge. And now because oxygen will have a delta negative charge and hydrogens will have a delta positive charge, it is possible for the hydrogen to get attracted to a delta negative oxygen of another water molecule. And that attractive force between the delta positive hydrogen and the delta negative oxygen is called the hydrogen bond. Now it's an orienting force in ice, because we have already seen the structure of ice, which is a tetrahedral array, and therefore that tetrahedral array is able to maintain its crystalline lattice due to this hydrogen bond. The hydrogen bond holds the atom together in their place so that they can maintain their tetrahedral structure. It's also responsible for the open structure that causes it to have a density below liquid water, because we have already seen that since ice has a crystalline structure, it has some hexagonal spaces in between, because it has to maintain its crystalline structure, so no molecules are within the tetrahedral array, and therefore because it is taking up more volume, it has less density. Again, if you can remember that volume and density is inversely proportional to each other. So if we have a high volume, we have a lower density. So because ice in its solid form has a higher volume, that's why it has a lower density than liquid water. Now let's look at the unusual property of water, the fact that it has a high density. This allows ice to float on water, because again, if something is less dense, it will float on a substance that is more dense. So if you have any other solid, such as a metal, which has much higher density than water, and if you put it in a glass of water, the metal will sink to the bottom of the glass. But with ice, because it has a much lower density, if you put ice in water, it still floats on the top. It does not reach the bottom of water. Hence, it's very unusual property of water. So the strong orientation of hydrogen atoms to oxygen atoms in adjoining crystal result in inefficient packing in the crystal. So as you can see in the diagram, the hydrogen atoms, which are the small green balls, and the oxygen atom, which are the larger yellow balls, they are arranged in a very, very ordered crystalline lattice. And you can see the spaces between the lattice, and those spaces cannot be occupied by any other molecule. And therefore you can see that they are taking up a lot of volume, a lot of space. And therefore the ordered molecular structure of frozen water causes it to have a lower density, again because the volume is much higher. The structure has a large hexagonal hole. So it's again emphasizing on the fact that it has holes. Nothing covers those holes, and because of those hexagonal holes, the volume of ice is much greater, and therefore the density is much lower. And hence, water has this unusual property where the density of the water decreases with the temperature. Now let's look at how this has a major role in our environment. So when ice forms in cold weather, it covers the top of water. Again, it insulates the water underneath it. So it acts as an insulating layer. So this insulates the water below. So if ice were denser than water, what would happen? If you put something more dense than water, it will sink to the bottom. So we don't want that because we have living things living in our water systems, right? So if ice were denser than water, ice forming on top of the lake would fall to the bottom and the lake would freeze solid. So the whole water body would freeze. Again, if the whole water body freezes, aquatic life cannot survive. Because why is that the case? Because everything will freeze. And again, aquatic life cannot remain in ice. Everything will die out, and we do not want that. So because ice acts as an insulating layer which prevents the water at the bottom to freeze up, aquatic life can still maintain even though the top layer of the water has become ice. Now let's look some other unusual properties of water. So water pipes can split in freezing weather, and why is that the case? Because we know that solid ice takes up much more volume than liquid water. So if you have water in the pipe, so when the water freezes, it will expand. So if it expands, it will split the pipes because the pipes only can contain a certain amount of volume. If the volume of the ice increases more than that, the pipes will split, and we don't want that. So again, with car radiators as well, they will break if water freezes in them, because again they also have a certain ability to contain a certain amount of volume. If ice goes past that volume, the radiator will break. And now to overcome that problem, we must protect these radiators and water pipes in very climate condition. And how do we do that? We add something. We add an antifreeze, which is ethane 1,2-diol. So when we add ethane 1,2-diol, it causes the water to still remain as liquid water even at lower temperatures. So it lowers the freezing point of water. So now when we add ethane 1,2-diol, water will freeze at a much lower temperature than it normally does. So the addition of this antifreeze provides water with extra properties, so it lowers its freezing point. So again, this lowers the freezing point of water so that it does not freeze even when the temperature is very low. So it drops below 0 degrees Celsius. So we know that the freezing point of water is 0 degrees Celsius. So at 0 degrees Celsius, water should turn ice. But if we add antifreeze, ethane 1,2-diol, it lowers the freezing point of water. So water will freeze at a much lower temperature. Also, salt can be added to water. So salt can be thrown on ice on footpaths to melt them, because again, salt lowers the freezing point of water. So if we add salt to water, it will freeze at a much lower temperature. So the freezing point is depressed, which means decreased, by dissolving salt solute. Okay, so again, if we add antifreeze such as ethane 1,2-diol, or even if we add salt, what they do is they change the property of water, that is to decrease the freezing point of water. So water freezes at a much lower point than 0 degrees Celsius to convert to ice. Now let's look at some the property of water as a weathering agent. So how does water causes physical changes or chemical changes in rocks? Now what does weathering mean? Weathering means the breakdown of rocks, so it can be physical or chemical. So physical weathering of rocks occur in cold climates. So first, the most effective process is the alternate freezing and thawing of water in cracks of rocks. So as you can see in this picture, that there is water in the crack of the rock body. Now we know that when water expands, when water freezes, it expands, so it takes up more space. And as you can see in the previous diagram, when it was just liquid water, it's taking up less space. But again, when it freezes to ice, you can see that the crack actually increased, the hole increased. So that means what they're doing is they're splitting the rock body. They're splitting the rock body, and then at one point the whole rock body splits when the water converts to ice and the whole thing expands. Now let's look at an example of chemical weathering. Now you are probably thinking, what is the difference between a chemical weathering and a physical weathering? So why are we using these two different words, chemical and physical? Well, physical is just the breakdown of substances. It does not produce a new substance. The substance stays the same, so rock will remain the same rock if it's a physical weathering. But if it's a chemical weathering, the rock will convert to another substance. So for example, the minerals in the rocks will change in a chemical weathering and form new minerals, and as a result will form new types of rocks. So in chemical weathering, we can form new products as a chemical reaction occurs, but in physical weathering, we do not form any new products. The rock stays the same rock, but it just breaks. It just decreases in size or splits apart, forms two different lands. So that's the main difference between a chemical and a physical reaction, that is a chemical and a physical weathering. So let's look at an example of a chemical weathering. So because it's chemical weathering, we want a new substance to form. So let's see how that works. So calcite mineral is found in limestone. Carbon dioxide dissolves in rainwater, because again, if you collect rainwater and you measure the pH of rainwater with a pH meter, you will see that the rainwater is quite acidic. It will have a pH around 5.6 or 5.4, whereas a pH of neutral pure water is 7. So therefore, rainwater is quite acidic. So carbon dioxide dissolves in the rainwater or stream water to form carbonic acid. So it forms a carbonic acid, and that dissolves the limestone, forming limestone caves, for example. So let's look at the reaction. Carbon dioxide plus water forms carbonic acid. Now again, I just want to emphasize on the fact that any chemical reaction that you talk about in your HSC exams or even in year 11, make sure you write your reaction with any chemical reaction that you're stating, because even if it's not mentioned in a question to provide a chemical equation, when you are getting marked, they will look at the fact that if you have or have not provided a chemical equation, because again, it's chemistry, so you have to know the chemistry behind each of the processes that are occurring. So you need to know what reactants or products are coming together in a chemical reaction. And again, you have to always provide a chemical equation with any chemistry that you are providing in your answers, because even if it's not mentioned in the question, they will mark on your chemical equations. And also make sure your chemical equations are balanced. So calcium carbonate reacts with carbonic acid to form the more soluble calcium hydrogenate carbonate. So again, you have to provide a chemical equation to show the chemistry behind. So we know that calcium carbonate solid, which is limestone, reacts with the carbonic acid formed by the rainwater, and it forms calcium hydrogen carbonate, which is aqueous. That means it dissolves it, so it's formed it's remaining as in the form of ions. Now let's look at water as a weathering agent. So again, let's look at how glaciers, what glaciers do. So you know glaciers are ice water bodies. So glaciers wear away rocks and cause erosion. Again, what is erosion? Erosion is the breakdown of rocks. So it breaks down large bodies of rocks into smaller bodies. So glaciers wear away rocks and cause erosion as they move down the valleys under the force of gravity. So there you can see that the glaciers are moving down because of the force of gravity, because gravity causes us to stay on ground. So we do not float in air because of the force of gravity. Same with glaciers, they fall down because of the force of gravity, and this causes the rocks that come in their pathway to break. So they break the rocks, they erode them. Liquid water and water vapor chemically weather many rocks, making minerals, converting them into new minerals that are more readily eroded. Again, it's a chemical reaction. That's why we are looking what the minerals that were initially there, they are changed into new minerals, and again those new minerals can be much more easily broken. So also you can see both solid water in the form of glacier and liquid water can chemically erode our rock or physically erode our rock. So solid water basically does physical weathering because they only break down the rock, but liquid water is involved in chemical weathering because they are involved in changing the minerals. So they form new minerals. So liquid water forms chemical weathering, whereas solid water forms physical weathering. Now let's look at water as a natural resource. So how can we as humans use water? And as you would already know that we use water in our everyday life. For example, to wash ourselves, we also drink water. So our whole life is basically dependent on water. Water is a very, very important substance for living things on earth. So let's look at what are other uses of water other than washing ourselves or drinking it. So humans can use water for industry. So a lot of our chemical industries uses water. For example, to generate electricity, so we depend on water to drive our pump, which again helps us to produce hydroelectricity. We can also use water in farming, such as in milk production. We can milk production as well as meat production, and also to grow crops such as wheat and cotton. Again, this is a very common one because again, to grow plants we need to provide them with water, because we have already seen that water is a major reactant in the most important process that plants carry out, which is photosynthesis. So to grow crops or any other types of plant in agriculture, we definitely need water. And also, aquatic organisms are harvested from rivers, lakes, and oceans. So farmers can actually harvest fishes and other sorts of animals in water. So again, you can see that there is very, very important uses and also different uses of water by humans. So humans can also use water for recreational purposes. So we can use water to enjoy or have fun as well. For example, you can go swimming, which is again in water. You can also go sailing, which is again a recreational use of water. Same with skating as well as skiing. So again, you can see that water not only has industrial uses such as in agriculture or in other sorts of work, we can also use water to have fun, such as swimming, sailing, skating, and skiing, and as well as fishing. So you can see that water can be used in a lot of different recreational purposes. Now let's look at the significance of water as a natural resource. So not only do we use water from industry or for recreational purposes, if you can obviously we use water to drink. But what happens in deserts and other dry regions? They do not have readily accessible water, because again, if you remember, deserts are very dry. Everything is covered with sand. There is not much water in deserts. So what people do is they dig underground and they try to take up water that has not evaporated due to these high temperatures in deserts, and they try to use the water that are underground, which are still in the liquid form. So these techniques are known as aquifers. So aquifers are ground systems from where we can extract water. So aquifers are a valuable source of water for human consumption and agriculture, especially in dry regions. Again, in dry regions, we do not have water bodies because the temperatures are way too high for water to exist as a liquid state on the surface. So what we do is, where the temperature is much lower, that is under the ground, we take water from there and then we can consume that water. So fresh water for drinking is a valuable natural source. Again, water is very important for our body because our bodies, most of our important metabolic reactions that we need to live are basically dependent on water. So therefore, fresh water for drinking is very important. Also, large cities require access to large storage reservoirs. So you can already see that water has very significant uses as natural resource in our environment and also our everyday lives. So we also require water for animal husbandry as well as crop irrigation, again emphasizing on the important use of water in farming. Waterways are used for transportation of raw materials, fuels, manufactured products around the world. So again, we can use water as a transport medium because again, we can use ships and other vehicles to travel on water and take the materials from one place to another. So not only do we use water for industrial processes and for drinking and recreational uses, we can also use water as a transport medium. So it also helps us to go from one place to another. Now this brings us to the end of the theory session. Let's look at some questions to test your knowledge. So the first question tells us to define the term weathering. Again, the verb is define, so you need to provide a definition for the term weathering. So what does weathering mean? Now weathering is the breakdown of rocks into smaller pieces, eventually contributing to the formation of soil. So weathering is basically the breakdown of rocks, and water can act as a weathering agent. So as for example, if glacier, which is solid water, if they are flowing and any rock that comes in their pathway, they break that rock. And as you can imagine, if they continue to break the rock, at one point the rock particles would be so small that they will lead to the formation of soil. So what is weathering? Weathering is the breakdown of rocks into smaller tiny pieces which will eventually form soil. Now let's look at question 7. Question 7 asks us which of the following is true when salt is added to water. Now we know that when salt is added to water, it lowers its freezing point. So water freezes at a much more lower temperature. Therefore, option A tells us that it melts below 0 degree and it boils below 100 degrees. Now this is false, because again we know that salt lowers the freezing point of water, and therefore melting point and boiling point must be higher than 0 degree and higher than 100 degrees Celsius. Option B again tells us that it melts below 0 degree, which is wrong. Option C tells us that it's above 0 degree, which is correct, but it says that it's below 100 degrees, so option C is wrong as well. And therefore our answer is D, which tells us that it melts above 0 degrees Celsius and it also boils above 100 degrees Celsius. So this is the correct answer. Again, why is that the case? Because the freezing point is depressed by dissolving solute. So when we add salt to water, it lowers the freezing point of water. So that means water converts to ice at a much lower temperature than 0 degrees Celsius. Now question 8. Question 8 tells us to compare how liquid and solid water act as an agent of weathering. Now let's look at the verb. The verb is compare. Compare means that we need to look at the similarities and the differences. So compare does not mean that you only have to look at the differences. You need to look at both the similarities of water in solid and liquid states and also the differences of water in solid and liquid state. So water in the form of rain, river and ocean waves, which is in the liquid state, wear away rocks physically. Now again, the word is physically. That means that we do not form any new products, we just break them down. Example, waves hitting rocks repeatedly. So why do cliffs form? Because the waves are continually hitting the rock, which is breaking it down and then forming our nice cliffs. Water also causes chemical weathering. Now what is chemical weathering? Chemical weathering happens when we convert one mineral to another mineral. So we convert the minerals of the rocks into new different minerals, causing it to form new types of rocks. So water can also cause chemical weathering. It dissolves carbon dioxide from air, for example, forming carbonic acid, which dissolves limestone. Water seeps into cracks in rocks as well. Now here it can freeze in cold weather. Now this is chemical weathering due to solid state, and it expands in the rock because we know as rocks cool down, solid ice has a much more high volume, so it expands in the rock, which causes the cracks in the rocks to increase, eventually splitting the rocks. Also, ice of glaciers, which is again in the solid state, grinds rock as the glacier flows downhill. So again, solid state causes physical weathering mainly, whereas liquid state can cause both physical weathering and both chemical weathering. So the question tells us to compare. So let's see what are the similarities. The similarities is both liquid and solid can cause physical weathering, but what is the difference? Liquid can cause chemical weathering as well, but solid water cannot cause chemical weathering. It can only cause physical weathering. Let's look at question 9. Question 9 tells us to explain why water is used as a coolant in cars and in industry. Now again, make sure you notice that the verb is explained, so you have to provide the cause and the effect relationship. So you have to provide details, you have to provide the chemistry behind why something occurs. So why water is used as a coolant in cars and in industry. So we know that water has a relatively high heat capacity. And what does that mean? Because it has a high specific heat capacity, that means we need to provide a lot of heat energy to convert the temperature of water, that is to increase the temperature of water by 1 degree Celsius. So because it has a high heat of capacity, it can absorb a great deal of heat, and this will cause only a small temperature rise. So water does not heat up really quickly. It can only, because it can absorb a great deal of heat as it has a very high heat capacity. And water tends to be relatively cheap and more plentiful than other liquids. So that is another reason why we can use it as a coolant. But the main reason is because it has a high heat capacity. So even if you can't remember this, make sure you can remember this and relate it to its chemical property, which is high heat capacity. So because it has high capacity, it requires a lot more heat to change its temperature. Also, it means that it can absorb a lot more heat, so it can stay cool for a long period of time, and that's why it's used as a coolant in cars. Now let's move on to question 10. Question 10 tells you to explain why the extremes of temperature in the ocean are less than those on land. Now, again, the verb is explain, and that means you have to provide a cause and effect relationship in your answer. So you need to provide the chemistry behind why something is happening. So you need to provide the answer in much more detail. So water has a high heat capacity, as we already know. And what does that mean? What implications does it have? It means that the ocean temperature changes much less than the land temperature, because land has a much lower heat capacity, which means that if we provide same amount of heat from the sun to both ocean and land, the land will heat up much more quickly than the ocean water. Why? Because again, water has a high specific heat capacity. The ocean needs a lot more heat energy to produce the same temperature rise as land. So again, if you want the temperature of the water to be as high as the land, you need to provide much more heat than the heat needed by the land itself to get to that temperature. So also water loses heat more slowly because again it has a high heat capacity, so it can contain a large amount of heat. Thus, the variation in temperature of the ocean is much less because again it has a high heat capacity, so it heats up really slowly as well as it cools down really slowly, and therefore the variation in temperature is much more stable, so the variation in temperature occurs much more slowly. Now this brings us to the end of the question session, and in this topic we looked at the different properties of water, such as hydrogen bonding and how it affects the density of water. Why is it so unusual? We also looked at the heat capacity of water and what role it plays in our environment.